Hello guys, so let's see this problem. Find polygon with the largest perimeter. So the problem statement, so a vector is given and with n elements. So all are positive numbers. So we need to find out a polygon means which have at least three sides, and we need to find the longest side of a polygon is smaller than the sum of its other side. Okay. So this is the condition to create a polygon. So basically return the largest possible perimeter of a polygon whose sides can be formed from nums. Okay. So basically this is the given condition, means there are n elements given in the num. So we can create the polygons by using that elements, but the condition is that the maximum number, which is the greater number of all among them, it must be smaller than the sum of the rest of the numbers. Yes. So this is the condition that I need to satisfy. Let's try to understand by example number here 2. So basically 1 1. So if you see like here, if I write 1 1 2 5, okay, sorry, 2 3 5, I sort it and then I write so 12 and 50. 1 12 1 2, okay, 1 1 2 3 5 12 50. Okay, so like what I need to do, 50 is the largest number. So first I will check whether the sum of the rest element or else sum of the all the elements including 50, if it is greater than the current 2 into the current number, then it's okay, then I can allow to consider this whole number to make a polygon. But if I am not allowed, if condition not satisfied, it means that I have to remove that greater number. So I think the sum of this up to this number is 224 437 7512 and 24. So 24 and 50, so 50 is the greater number. So I cannot consider this 50 into my polygon that I need to form, because it is not satisfying the condition. The greater number must be smaller than the sum of the rest numbers, but it is not satisfying the condition. So now again, if I see the sum of the up to this element, that is 12, and up to this 24. So 24 is lesser than 2 into 12. No, it's again equals to 2 into 12. So again I can't take it, but it must be smaller. Now if I talk about here, so 3 plus 2 5 to 7. Yes, now 7 is greater than equals to 5, or I can say 7 plus 5 12. So 12 is greater than 2 into 5, that is 10. So this is the, so now I can make a polygon with by taking these elements, that is 1 1 2 3 5, that is equals to 12. So this is all about the problem statement, and I have taken the example number 2 to explaining the. So basically what is the idea, the basic idea, the brute force is just to sort it, sort the array, and just take first take the sum of the all the numbers and then start with the largest number by checking how I checked here, that I have already shown you. So basically to sorting, it's taking n log n, and after that I think it's very easy to understand. I'm going to talk about you the big O of n time complexity solution that is given by Lee. So I'm going to tell you what is the idea and approach of that solution. Okay, so what can I say here? Like it's a big O of n time complexity solution. So instead of sorting, if I use a priority queue, in priority queue, if I insert n elements initially, it only takes big O of n. And but now here question arises, okay, it is taking big O of n. Why it is taking big O of n? I will give you a link how it's like. I have to talk about the implementation behind it. So I will directly just see the comment part. And now after that, but if I start checking with the greater element, because here I have first initially put all the elements in the max heap, and if I start with the max element by checking the conditions, so again now here question arises, how many times this loop is going to run, how many times this In the worst case, this max heap is going to pop out the elements. So the answer is max is 30. Now how 30? So basically, let me show you the host condition where it takes 30. 1, 2, 4, 8, 16, 32. So if you see, like if I start, yeah, like if I start my the same thing, so up to this element and up to this element, the sum of the numbers is it is basically 63, and sum of the last greater number into 2, that is 64. 64 is greater, so I need to remove it, pop out. So just pop out the last element. Again, if I do check the condition, again the sum is 31, and and 2 into 16, that is 32. Again it is greater, so again I need to remove. So in this way all the elements will be removed. So if you see, this is the host condition. It means 1, 2, 4, 8, 16. So basically this series will go up to which number max value it can be take. So if I see the constant range is 10 to the power 9. It means that it it's around 2 to the power 30. That is up to 30. That's why the max number of pop out in the host condition that can be happen is 30 times. Okay, to understand more clear idea, to get more clear idea, let's see the code. I'm going to implement it. Okay, so first of all, I need the sum of the all the elements. So for that, long sum equals to 0, and just also take a answer variable. Okay, now equal to 0, I lesser than num dot size and I plus plus. Now sum plus equals to nums I. Now I need a priority queue. Okay, so max heap dot begin dot end. So this step, its complexity is big of n. Remember this. How? Just I have ping it into the comment section. So just read it once. How it's big of n. Now I need to pop out. So first of all, just check max heap must be not be empty. So max heap dot empty. So if it is empty, then it will give you true, so it becomes false, so it comes out from the loop. And now check the last element and the current sum. So the current sum is sum. If sum is lesser than or equal to the 2 into top max heap, like max heap dot top, to get the top element. If this condition satisfy, it means that I need to pop out that element. But before that, decrement your sum, because in the sum it's already stored. So just max dot top max heap dot pop. This is the condition. So this while loop at max 30 times run. Why? I told you already. As you see here, like it is the 2 times. So basically, if it is greater, the last element is greater than twice of the sum of the all the elements of that numbers, all the possible numbers that is there in the max heap. It means that it is forming a like a figure like 1 to 4 in the power of 2. So at max, it go up to 10 to the power 9. That's why it's 2 to the power 30. At the last, just check like max heap dot size greater than 2, because at least it is mentioned here the size is at least 3, so that's why max heap dot size greater than 2, and the sum, your sum is also greater than 0. Then at that time just return the sum, or else return -1. Okay, so I don't need this answer variable. Okay, let me run. Okay, so now the sample test cases are passing here. As you can see, the solution also get accepted. So I hope the solution is clear to you. That's all for this problem.